We're now going to go to where new land is being created. We're going to the islands of Vestmannaeyjar. Vestmannaeyjar is the name given to a group of islands off Iceland's south coast, most of which were formed during the past 10,000 years. There have been many eruptions here, and although the majority of these have been submarine, some have built new islands. The two most recent eruptions created the island of Surtsey in the 1960s and added to the existing island of Heimaey in 1973. But why are new islands being created here when the nearest spreading ridge is so far away? When we look at the composition of the basalts erupted in Vestmannaeyjar, we get a surprise. These basalts are silica undersaturated. They are alkali basalts. This suggests that something different is happening in the zone of melt generation beneath these islands. Here's a west-east cross-section along Iceland's south coast, from the western rift zone on the left to Vestmannaeyjar on the right. The olivine tholiites erupted at the western rift zone are generated by about 20% shallow partial melting of the mantle. In contrast, the alkali basalts erupted at Vestmannaeyjar are generated by smaller degrees of partial melting at much greater depths. The slight bump on the solidus under Vestmannaeyjar suggests that something is affecting the thermal structure of the lithosphere in this area. We'll look at this later, but for now, let's summarise what we've uncovered about the eastern rift zone. In the eastern rift zone, we've seen a much wider range of basalt types. We have quartz tholiites, olivine tholiites and alkali basalts, but there's much more quartz tholiite in the eastern rift zone. Alkali basalt is only found in abundance in the islands of Vestmannaeyjar. Now there's a model that puts all this together. The eastern rift zone is seen as being a young, developing rift that's propagating its way through older, pre-established crusts. But we still need to explain what triggers the partial melting deep beneath Vestmannaeyjar that produces alkali basalt primary melts. This is a cross-section from Barðabunga to Vestmannaeyjar. Notice how much thicker the crust is at Vestmannaeyjar. Now remember that the eastern rift zone is propagating to the southwest, and that two consequences of this are that erupting tholiites travel in the crust to the southwest, and, more importantly, that there is lateral flow of hot mantle towards the southwest. This changes the thermal structure of a lithosphere, and the zone of melt generation has only recently reached as far as Vestmannaeyjar. So here is the explanation why silica undersaturated basaltic magmas are erupted at Vestmannaeyjar.